Hello, welcome to my video on arrays in Java. Today, we'll be going over arrays, how we can use them, and much more. So, what are arrays and how are they useful? Arrays are data structures that consist of a group of elements of the same data types, where each element has its own index number with the first element of the array possessing an index number of 0. Arrays are immutable data structures, meaning they cannot be changed. Arrays are useful because different variables can be stored in one single array, to where there is no need for creating many variables hold these values, and so we can easily access these variables by specifying the index of the array. Essentially, all elements of the same data type are stored in one array, and we can easily access these items by just referencing the array along with the index number in brackets, depending on which element is desired to be accessed. So now, let's see here. In what ways can arrays be created in Java? And what kind of data can they store? Well, if we go over here, we can see some comments I've made regarding creating arrays, storing data, and whatnot. So let's go over this. The format for declaring an array starts with defining the type of the array, which specifies what data type items in the array will take on. This is then followed by typing out square brackets, then after, typing out the name of your array. So as shown, data type, square brackets, then name of array. We have just declared our array. This is just the beginning. We are able to create an array of any type, whether that be an array that stores string, integer, or double values. So, as shown here, we've created one array called weekdays, which stores strings, another array called my favorite numbers, which stores integers, and one other array called GPA students that stores double values. We also created an integer array in another way, to where we first declare an integer array, followed by square brackets, which is then followed by the name of our array. Now, we will get back to this just in a moment. So, how do we actually store and access data in already existing arrays? Well, like I said, we've already declared our arrays, and you also have to initialize them. As shown here, in order to store data within our array, we would first put our equal sign, followed by curly braces. Within our curly braces, we shall store our data. Each item we store within the array is separated by a comma. So for example, if we look at our weekdays array, each item in this array is separated by a comma. So for example, the string Monday, string Tuesday, string Wednesday. Notice how they're all separated by commas. We also did that for here in this integer type array, my favorite numbers, so where we separated each integer with a comma. So here 11, 7, 16, whatnot. We also did that in this double type array, 3.8, 4.2, 3.5, etc. In our integer array called random array, we've done things a little different. After the equal sign, we use the new keyword to indicate a new array object being created, followed by the int keyword, followed by square brackets. That's a lot of follows, but anyways, within the brackets, we will specify how many elements we want within our array. In this case, we have put 3, to where we will have 3 total items in our array. Each item will be set equal to 0 by default. Now, in order to access data from an array, we would need to specify the index of the specific piece of data we would like to access. In an array, we begin counting from the beginning with the number 0 rather than 1, and so the first data piece corresponds to the number 0, the second corresponds to the number 1, and so on. Accessing the data from an array requires listing the name of the array, followed by square brackets, and within these brackets, placing the index number of the element we'd like to access. So as you can see within these comments, I've actually highlighted it right here, just now. You need to list the array name, followed by square brackets, and within these brackets, put the index number in order to actually access the data from arrays. So, for example, if we wanted to access the third element of the weekdays array, which is Wednesday, so 1, 2, 3, Wednesday, right here, We would first use our print statement, obviously, then list the array name, followed by square brackets with the index number of 2. We would also do the same for the my favorite numbers array, where, in order to get the first item, 11, we would have to use a print statement, then, within the statement, list the array name followed by brackets containing the number 0, which represents the first element of the array. We'd also do the same for GPA of students, where, in order to access 3.4, the fourth element of the array, so 1, 2, 3, 4, right here, we would have to specify its corresponding index number, which is 3. Now, it's no different for the random array either. So, sorry, I said that wrong, the random array. That's 2 arrays in one sentence. Anyways, to access an index from the random array is no different. We will indicate the name of the array within our print statement, followed by brackets, followed by the index number corresponding to a specific element in the array. We will use 1 in this case, which prints out the second element of the array. So, let's run our code and see what happens. As you can see, we were able to access our data from the arrays. So right here, ignore these. So, we accessed the string Wednesday from the weekdays array, the integer 11 from the my favorite numbers array, the double value 3.4 from the GPA of students array, and the integer 0 from, well, the number 0 from the random array. Again, this kind of array, this integer array, creates an array of integer base values that are all equal to 0. And in this scenario, there would be 3 elements within the array, as I've just written right there. So, you get the idea. So, how can an array be traversed using a for or while loop? You can traverse an array with both while or for loops. So, you would create a simple for loop, as shown here. Create an integer I equal to 0, set I less than the length of the array, which in this case is weekdays, and add 1 to I on each iteration of the loop. Now, the length of weekdays is equal to 5. However, we know that when dealing with index numbers, everything starts with 0, which is why we set I equal to 0. And we will continue to add until it becomes equal to the length of weekdays. So when it is equal to the length of weekdays, essentially the loop would terminate and it would end completely. So it will print indexes 0 through 4, which are basically corresponding to elements 1 through 5. As you can see, we put a print statement within the for loop that prints out the array plus the variable I in square brackets, which is essentially the index number. And the value of I will change in correspondence with the current iteration of the loop. For example, if we are in the third iteration, 2 will already have been added to I, and so I will be equal to 2. Thus, the third element of the array will be printed. For the third element in any given array is given an index number of 2. Basically, we've accessed an element of the array within the loop, and this statement is executed on each iteration of the loop until I is no longer less than the length of weekdays. So let's clear this and run our code again for clarity purposes to test this out. So as you can see, we've successfully traversed the weekdays array using a regular for loop. Now, we can also use a while loop to traverse an array. Let's make use of the my favorite numbers array, to where we'll use a while loop to traverse through it. We've created an integer variable called I, right here, that holds the value of 0, and the loop will start from here. The length of the my favorite numbers array is 6, and the loop will continue running while I is less than the array's length, which is again 6, and it will stop when it reaches 6. So it won't execute once I is equal to 6. Keep in mind that on each iteration of the loop, I increases by 1. So on the first iteration, the first element with an index number of 0 will be printed out. Second iteration, the second number with an index number of 1 will be printed out, and so on. We also access elements of the array in a similar fashion as we did in the for loop, to where we utilize our I variable to gain access to elements of the array by utilizing index numbers and printing out the index numbers corresponding item. So, for example, if I is equal to 4 on the fifth iteration of the loop, the fifth element will be printed out, and we've already gotten the gist of it. So, let's move on to running our code and seeing what happens. So, with this while loop right here, as you can see, each item of the favorite numbers array was printed out. So 11, 7, 16, 12, 13, 4, and yeah. Now, what's an enhanced for loop, and how can it be used to access an array? An enhanced for loop is essentially a for each loop that acts as an iterator for elements within collections of data such as arrays. Being simpler than our previous for and while loops, an enhanced for loop does not require utilizing index numbers to print each element out. 4. The purpose of an enhanced for loop is simply to iterate through every item of an array from beginning to end. To construct an enhanced for loop, we will have to first use the for keyword, followed by parentheses. So right here. Within these parentheses, we will designate a variable with a specified data type that corresponds to the data type of the array. So for example, we're looping through the GPA of students array, and it's a double type array, so we have to use this double keyword on the variable number. Anyways, we will follow this variable with a colon. And right after the colon, we will list the name of our array. So GPA students. This is the array we will loop through, obviously. We are done with our parentheses. And we will put curly braces afterwards. To where, within these braces, we will put a print statement that prints out our number variable. Now, on the first iteration of the loop, the first element will be printed, which is 3.8. So right here. Then the second element will be printed on the second iteration, third element on the third iteration, and so forth. So, number changes depending on the current iteration of the loop. Say it is the first iteration. Number will be equal to 3.8. Second iteration, number will be equal to 4.2. So as shown here. Third iteration, number will be equal to 3.5. And you get it. You get the gist of it, really. It's going in order. So, an enhanced for loop, as you can see, is much more simple to create than a regular for or while loop. I mean, this was done in 3 lines. I mean, they're both pretty easy to make, but I'd say for each loops are much more simpler in my opinion and more efficient. Just less things, less complications. So just personal opinion. But let's run our code and see what happens with this for each loop. So right here, we've managed to loop through our GPA of students array successfully using an enhanced for loop. That's great. We've successfully iterated through the array with enhanced for loop. Now, in Java, it's important to understand potential errors you might encounter when working with arrays. And I actually spelled arrays wrong there. Maybe a Grammarly mistake fixed that. I'm not even sure. Because I remember typing out arrays with an A. But anyways, errors that you might encounter when working with arrays are actually more common than you might think. It's important to understand some errors that might be incurred when working with arrays in Java. One specific error encountered is when we're attempting to traverse through an array with, say, a for loop. So right here, for example. And we accidentally request for an index number that is equal to or greater than the length of an array. This would raise an arrays index out of bounds exception. This is because we tried accessing an element of the array that does not exist. We know that the first element of an array corresponds to an index number of 0. The second corresponds to an index number of 1, and so on. So, the highest index number possible for an array will be equal to the value of the length of the array minus 1. We cannot access anything greater than that. So, for example, if we look at our code here, within this for loop, we have attempted to traverse through the weekdays array. So, as you can see, that was successful because we got no errors. But if we add an equal sign, let's see what happens. Oh no, we got an array index out of bounds exception printed out on the console. Well, if we look after this, it says index 5 out of bounds for length 5. Well, what does this mean? Well, I just said that the maximum index number possible is equal to the length of an array minus 1. So, how is it possible for there to be an index number of 5 if the maximum index number here possible is 4? Exactly. Now, we also did say that the first element of an array corresponds to an index number of 0. So, if there are 5 elements in the array, don't you think the fifth element would correspond to an index number of 4? Exactly, right? Because an index number of 5 would imply that there's a sixth element, but there is not a sixth element. No, because if we go back to our weekdays array, we can see there's clearly 5, and of course there's 5 days in a week, so that's something I already know off the top of my head. But you get the idea. So, when we put this equal sign, it means that the loop will calculate index numbers all the way up to an index number equal to the length of an array. And so, the maximum value for an index number is no longer the length of an array minus 1. It is the value of the array's length itself. And as just said, there are 5 items in the weekdays array corresponding to index numbers 0 through 4. So, when we try to generate an element with an index number of 5, really, what we're trying to do is access the 6th element of the array, but this element does not exist, which is why this exception was raised. So, let's fix this again. Sorry, let's fix this. Not again, this is something new. I don't know why I said that, but as you can see, we no longer have an error. That's great, and we've successfully traversed through the loop. So that's one error you might encounter in Java. Wow, that was great. But we still have one more error that's also very common to say. There's one other error as well that's very common in Java, which is an error encountered when working with arrays is when trying to print out the length of the array. Generally, for arrays, as shown here, for example, we would access the value of the array's length through first indicating the array name, followed by a period, which is then followed by the length keyword. So that's how you get the length of an array in Java. However, some people get mixed up because when trying to find the length of an array, for example, they might incorporate parentheses. They accidentally incorporate parentheses when writing out the length keyword while attempting to access the value of the array's length. Because for strings, see, I'll actually type it out right here. Say we have a string. For example, this name is hello. Generally, to get the length of a string, you would just do x.length, but with parentheses. Now that's for strings, but that's not for arrays. But yet, some people still get mixed up. Now, we obviously get no arrays no errors, because as you can see, our code did not have any errors with it when we ran it in the console. But let's add parentheses and see what happens. As you can see, we get an error, cannot find symbol. This is because errors utilize the length keyword without parentheses. Incorporating parentheses will give us an error. because Java cannot find the symbol. Well, it's because you can't get the length of an array with parentheses. You have to actually remove these parentheses. And once we remove the parentheses, I accidentally removed one extra one. But once we remove the parentheses, as you can see, we're all set and everything works. Now that's all great. Now, those were just two errors or some errors that you may encounter in Java when working with arrays. Now, let's see how we can use standard algorithms when working with arrays. Alright, one way standard algorithms can use arrays is to determine the maximum value of an array. Really, here we're getting the max value of an array by first creating an int max variable equal to 0, and then we traverse the array parentheses, depending on what array it is, and we check for a value that's greater than max. We keep on doing this until eventually there's no value that's greater than max, and then if there is a value greater than max, max will be set equal to that element. Else, if it doesn't find anything else, then it'll just keep on going through without changing the max variable. As you can see, we return max at the end. Standard algorithms can use array to determine the minimum value as well. So for example, if we set the first element of an array as the value of our int min variable right here, and we traverse through the array, if we find an element that's less in value than the min variable, then min will be equal to that element. And then once we're done, we'll just return min. And in addition, this will all become more clear once we actually look at the code being in practice or being in use, sorry. In use, yeah. We can use standard algorithms when using arrays to compute the sum of an array as well. So we create our sum of array variable and then give it the value of 0. Then using an enhanced for loop, we traverse through each element and then add it to the sum of array. And then our sum of array will just hold all these values added together. Then we will return this at the end of the method. We can also compute the average of numbers in an array to where we again hold our values in one variable and then loop through each element in the array and then add this to sum, and at the end we divide sum by the length of the array. And that makes sense because you have to divide by how many pieces there are. For example, if there's like 5 elements in your array, then you'll add all the elements together and divide by 5. That's basically how you get the mean or average. And yeah, I know you also use a double keyword to get a double value because if I'm not mistaken, averages are pretty precise or pretty exact, so you can't really round with those, so you have to return a double value like here. And that's why I have the double keyword in my method and I return double sum divided by array length. Now you can also compute the mode of an array to where you create num count, current mode, interior count. I'll explain these variables as we go on. You create a simple for loop, then within that another for loop to where you check if this, so for example, you check if array x is equal to array I, you would add this to interior count, basically implying that we're checking for duplicate values, but except we're checking which value has the most duplicates itself, which is essentially the mode. And then, right after all this, if array x is equal to array I, we add 1 to interior count, and then we check, is interior count greater than num count? If so, num count is equal to interior count, and then current mode is equal to array x, which is basically the current element that has the most duplicates at the time. Now we'll keep on doing this and over, iterating again until we find a value to where its interior count, basically how many times it appears, is greater than the previous num count. If so, then that becomes the new mode, or the current mode. And then at the end, we just return current mode, and then that's how you get the mode. Pretty neat. We can also determine if at least one element has a particular property, which in this case is being equal to this element. So we have a Boolean checker value. We traverse using an enhanced for loop through the array, and then we check, okay, is this element equal to that? Is this element equal to the element indicated in parentheses? If so, then we'll just automatically break out of the loop, and the checker will be set equal to true, and then return checker, implying that when checker is true and the method returns true, that there is at least one element in the array that has that particular property of being that element. So for example, if we try and find an element that's equal to 1, and at least one element in the array is equal to 1, we'll return true. We can also determine if all elements have a particular property. I don't know why I put parentheses there, but that's just a comment, so it's pretty meaningless. But you can use this as well to check if all elements have a particular property. So say we wanted to find if all elements are even, if all the elements in the array are even. We would do that by creating this method, utilizing this Boolean variable, setting it equal to false. We have to set it equal to false at the beginning because if no matches are found, then we'll just return false. But if a match is found, then this changes to true, and then we return true at the end. So for example, we'll traverse through each element in the array using a enhanced for loop. And then we say if item modulus 2, basically applying modulus 2 onto item, is not equal to 0. So if it was equal to 0, that would imply that it's even. But if it's not equal to 0, that implies that it's odd. So if we find an odd element, that will already mean that not all elements in the array are even. So we'll immediately break out of this for loop and just return false, which is checker. But if all elements in the array are even to where the statement is false for each and every item in the array, checker becomes true. Alright, we can also access all consecutive pairs of elements. So, for example, we'll create this method, return consecutive pairs. We created an array list, actually. We imported java.util.arraylist right here at the beginning. We imported the array list right here. So, to where we can use array lists. Java.util.arraylist. Yeah, you get the idea. So, where is it? Sorry. Alright, so we create this array list elements, and then for each, we use a for loop to traverse through the loop, and then we do for int I equals 0, I is less than array length minus 1, I plus plus. If array I is equal to array I plus 1 minus 1, basically you get the element after the array, but then you subtract 1 from it. Then you add those pairs of elements to the array list. Basically what this is doing is, for example, if array I is 1, and then the element, if array I is the first element, and then array I plus 1 is the second element, and you subtract 1 from it, which would basically say, imagine this is 1, imagine this is 2. Since they're 1 apart, you would subtract 1 from it to see if they're equal if you do subtract 1 from it. If so, you add that pair to array list. And then print out elements at the end. Yeah, you'll see this will become more clear once we actually run the code. We can also determine the presence or absence of duplicate elements. So, right here, we create our boolean as our duplicate, which is all by default false. But if we do find a duplicate, this will be set equal to true, and then we'll return is there a duplicate, which is true. But if there is no duplicate found, then it will just be returned false. So we'll loop through the array and then with a for loop, and then put another for loop inside, and we'll check if array is equal to array x, which is basically saying it'll loop through the loop and look for duplicates of the element, which yeah. So for example, if array I is equal to array x, say array I is 1 and array x is also 1, then this will be set equal to true. And we have actually two loops concurrently running, which makes sense because we want this loop to first check array I, and then this will check the elements after it, including I as well, but no, sorry, not including I plus 1. We'll check the elements after it. Then x is less than array length. You know how it goes. Then x plus plus it adds on each iteration of the loop 1 to it. And yeah. So anyways, once a duplicate is found, you return is there a duplicate, which is set equal to true. And then we can also determine the number of elements being specific criteria, which for this method is how many are odd. So we created a count variable, then we use an enhanced for loop for int item in array. If item percent sign 2, which means if modulus 2 being applied on item, for example, is not equal to 0, count is equal to count plus 1. And this is basically saying if the element is odd, because obviously an element that is odd, when applying modulus 2 onto it, it will not give you an answer of 0 if it's odd. If it was even, then it would give you a result of 0, but because we're looking for odd numbers, we use a not equal to sign. And then we add 1 to the count variable. Then at the end, once we're done with the loop, we just return count. Now let's actually go here and see how we use these. So for example, right here we use this array, and then using standard algorithms to work with arrays. We found the max number with our maximum of array function, minimum number with our get minimum of array function. And then yeah, we got the sum, average, mode, and then we checked if there's an integer of 1. As you can see here, we checked for one number. So we determined if at least one element has a particular property. 1 was our second parameter, then the array was our first. So if we checked for if the element 1 was within this thing, or sorry, within the array, um, all elements in an array of numbers are even numbers. That's obviously false because you know we have the numbers 1, 7, which are odd, so those all automatically make it false. And then as you can see, it's evident here to where we got false. Now we'll go over this coding, the console in just a second. Just going over what we printed out. All elements in an array of numbers are even numbers. We just went through that. Consecutive pairs of array numbers. Then we printed this out, and it was a void method, so it didn't return anything. We actually had to print out the array list itself, so that's why I printed it out on its own line. And then we checked for duplicates, and then we checked for odd numbers. So now let's go over what's in the console. Maximum number of array numbers 7, obviously, because all the rest are less than it. And 7 actually appeared 2 times, which was kind of cool, but yeah. Minimum number of array of numbers is 1. That's the least number. That was this function right here. And this line was responsible for getting the max number. This line was responsible for getting the minimum number. We got the sum of array numbers, which is 36. We added all these together right here. Average of array numbers 3.6. Um, Sorry, my mic is just really close to me. All right, I think that's better. We also got the mode of array numbers, which is 2. It appears the most. 1, 2, 3. 1, 2, 3. 4 also appeared 3 times. So let's test this. Let's just run it again to validate our answer for 2 being the mode. And there we go. We also got 2 again. Again, I think that was just, I think, okay, I was just making sure that we were checking for the integer 1, and that was printed out. So there's an integer of 1 in an array of numbers. Check for one number, array of numbers, comma 1. Yeah, that returns true, so we got true. This is kind of like a true false statement too. All elements in an array of numbers are even numbers, false. Again, we already went through that. Um, Consecutive pairs of array numbers. Notice that we printed out in square brackets and then in parentheses. So if we go back to the original function, we actually did that. Where is it? Right here. So array I, comma array I plus 1. Consecutive pairs meaning that like they're one apart in value. So 2 and 3 are one apart, 1 and 2 are one apart in value as well. There are duplicates in the array of numbers array. True. I mean, we got 2, 2, 2, 2, 4, 4, 4. I mean, pretty obvious. And then finally, number of odd numbers in the array of numbers array. 4. 1, 2, 3, 4. Yep. And that was on this line right here. So as you can see, we were able to use standard algorithms to do many things with Java and go through step by step in order to accomplish the task we needed to accomplish. I thank you for watching my video on arrays in Java, and I hope you have a wonderful day.